Calculus 3b, 6.2. Definition. Let's begin by a definition. Suppose you have two continuous functions and function f is greater than function g on an interval, closed interval a to b. So suppose you have a closed interval a to b, and this is function f, which is greater than function g. Then the area of the region bounded between these two is equal to the integral of f of x minus g of x, while x ranges between a to b. So here's a question. What if you don't know if f of x is greater than g of x or g of x is greater than f of x? Suppose you have two complicated functions and you don't know which one's which. In this case, in general, you can say that, hey, area is absolute value of the integral f of x minus g of x. So you can always take the absolute value of the integral, and the outcome as an area is always positive. Here's example 1 for you. Question says, find the area of the region bounded between two nice graphs. The first one is a quadratic function, 5 minus x squared. 5 minus x squared. And the second one, another quadratic function, x squared minus 3. Okay, note that here you don't know what is A and what is B. Get back to the definition. The definition said, if you have two continuous nice functions on a closed interval, then the area bounded between these two functions is equal to the integral of the difference between these two functions as x ranges between a to b. So in our first example, the lower bound and upper bound are not given. What we can do, we can set these two functions equal to each other to find a and b. Set f of x equals to g of x. When you set them equal to each other, you get, so 5 minus x squared equals to x squared minus 3. You get 2x squared equals to 8, or x squared equals to 4, and you get two solutions. X can be 2 or negative 2. So the lower limit and upper limit, as you can visualize, the area bounded between these two functions ranges between negative 2 to 2. Okay, we have everything. We have the lower function, we have the upper function, we have lower bound, we have upper bound. We can definitely follow the formula. Formula says the area is equal to the integral negative 2 to 2 f minus g. Again, you could write g minus f and finally put it in absolute value. Is equal to 5 minus x squared minus parentheses. Don't forget about the parentheses because the second function has two terms. Then we distribute the minus sign, we get 8 minus 2x squared dx. Okay, take a look at this area. First of all, you have symmetry. Because of symmetry and because you have an even function. This function 8 minus 2x squared, if you investigate, it's an even function. So you can find the integral between 0 to 2 and multiply it by 2 to get the total area. The integral of 8 is 8x. You know that 8 is just a constant, so it is 8x. And the integral of 2x squared dx is equal to 2 the integral of x squared dx, which is 2/3. Remember that we have a power rule here. 2/3 x to the third. So you have 8x minus 2/3 x to the third, and you multiply by 2. Now you range x between 0 and 2. Don't worry about 0. You have x and x here. If you plug in 0, the outcome is 0. So just plug in 2 and do the calculation. The outcome, the total area, is 64 divided by 3. Next page. Perfect. Now we have some interesting functions. This example says, hey, find the area of the region bounded between the graphs of f of x, which is equal to negative x squared plus 3x plus 6, and g of x equals to absolute value of 2x. Perfect. First, try to visualize what's going on here. We know that the first function is just a quadratic function. The second function is absolute value function. So what's the region bounded between these two? How to graph these two functions? How to find the upper bound and lower bound of the region between these two functions? The first one is easy. It's just a quadratic function. It's not very hard to visualize this quadratic function. And since the leading coefficient is negative, you know that it's a concave graph. It opens downward. The second function is absolute value of 2x. Remember that. Recall. Absolute value of x is equal to. If x is greater than equal to 0, it is x. If x is less than 0, it is minus x. This is the general definition of absolute value function, which is the distance from x to the origin. Perfect. So absolute value of 2x is equal to, when x is positive, of course you get 2x back. If x is negative, you have minus 2x. So when x is positive, you just have a line 2x. When x is negative, you have a decreasing line minus 2x. So the upper function, f of x, is negative x squared plus 3x plus 6. And lower function is a piecewise defined function. On the left-hand side, you have g of x equals to minus 2x, just a line segment. On the right-hand side, you have g of x equals to positive 2x. This is the region bounded between these two functions, and we're looking for our a and our b. So, as you can see, on the left-hand side of y-axis, you have this region bounded between function f and negative 2x. On the right-hand side, you have another region bounded between function f and 2x. So we have to separate the integral. We have to find the area on the left-hand side. We have to find the area on the right-hand side and add them together. So area bounded between f and negative 2x. The area bounded between f and positive 2x. For each of them, we have to find a and b, find the integral, and add them together. Okay, perfect. So, for your left-hand side, so on the left-hand side, you have f and negative 2x. To find a and b, set f equals to negative 2x and solve for x. So your function f of x, as you can see, is defined as negative x squared plus 3x plus 6. And you set it equals to minus 2x. Here we have a quadratic equation to solve. We add 2x to both sides. You get negative x squared plus 5x plus 6 equal to 0, or x squared minus 5x minus 6 equal to 0. You can write this in factored form. We're looking for two numbers. Their product is negative 6 and their sum is equal to negative 5. Those two numbers are 1 and minus 6. So your x is negative 1 or x is equal to 6. Okay. So we just found the lower bound a for the left-hand side graph. And we know that this area stops at 0. So we don't need 6. B is equal to 0. Area to the left-hand side. This is your area. This is going down. This is going up. This is the area that we're working on. It doesn't continue on the right-hand side. It just stays on the left-hand side. We have function f and we have function negative 2x. A is negative 1 and b is equal to 0. So this is area on the left-hand side. Now you need to find the area on the right-hand side. On the right-hand side, you have this part of the graph. This and line 2x. So now you need to find this area. The area a to b, f minus function 2x dx. So you can actually see your a or lower bound, your x is 0. So your a is 0. Now you need to find your b. How to find b? You set function f equals to 2x. So function f is negative x squared plus 3x plus 6 equals to 2x. So you get x squared minus x minus 6 equal to 0. You're looking for two numbers, their product is -6 and their sum is -1. So x can be -2 or x can be +3. Of course, you cannot accept -2 because this piece is on the right-hand side of x-axis. X cannot be negative. So your upper bound is 3. Very well. So now we just have to do the integrations and add the final values together. Integral on the left-hand side, -1 to 0, -x squared. So by subtracting these two and combining like terms, you get -x squared plus 5x plus 6. And the area on the right-hand side, -x squared plus 3x plus 6 minus 2 gives you -x squared plus x plus 6. Note that you cannot combine these two integrals because the lower bound, upper bound, lower bound, upper bound are different from each other. So you have to calculate each of these integrals separately and add the final answers together. So the integral of -x squared, remember that you have a power function, is equal to x cubed over 3. The integral of 5x is 5 halves x squared, and the integral of 6dx is 6x. All of these are nice functions, power functions, so all of them are following the power rule for the integral. Okay, then we plug in 0. The first term is 0, the second term is 0, the last term is also 0 because all of them have x. So you have 0 minus, now you plug in -1. -1 to the third divided by 3. Negative and negative, they cancel out each other, you get a third. Plus 5 over 2, -1 squared, which is +1. Plus 6 times -1, which is -6. Plus the second integral, you plug in 3, you get -3 to the third, 3 times 3 times 3, divided by 3, or -9, plus 3 squared, which is 9, divided by 2, plus 3 times 6. When you plug in 0, all of these terms have x in them, so the outcome is 0. If you add these two numbers together, the outcome is equal to 50 divided by 3, which is the total area. See what's going on? Okay, so far we found the integral, found the area between two curves with respect to variable x. Now, what if it's more convenient to take the integral with respect to variable y? The formula stays the same. The area is equal to the integral of f of y minus g of y dy. So here you have your functions with respect to y, and your y value ranges between c and d. So it's like this. So you're finding the area between two functions, and now you're saying that, hey, instead of taking the integral with respect to x, I can take the integral with respect to y, c and d. So here's an example for you. Suppose you have two functions, y equals to x cubed and y equals to x plus 6. Question says, find the area of the region bounded between these two functions and x-axis. First of all, let us graph these two functions, see what's going on. Y equals to x plus 6. This is just a linear function. You can graph this function using any table. This function is x cubed power function, and you know the behavior of this function. Perfect. It's also bounded below by x-axis. So always read the question carefully. It's bounded between this line, this function, and horizontal axis. You're looking for the area between these functions. Perfect. So first, let us use the method that we learned in previous page. Method 1, just taking the integral with respect to x. Area is equal to the integral f minus g dx. X ranges between a to b. Okay, perfect. So if we want to use the first method, it's like previous example. Here, your function x plus 6 is a linear function. So the upper function stays the same. This is your f. But down here, you have two different functions. This is function y equal to 0. So it's equal to the integral f minus 0 plus the integral f minus x cubed. We have to calculate two integrals like previous example. One on the left-hand side, bounded between the linear function x plus 6 and 0. The second one, the second portion, is on the right-hand side between f and this function, cubic function. And we cannot combine these two. There are different functions. We have to calculate them separately, find the integrals, add them together. On the left-hand side, you have this portion. To find the lower bound, you set x plus 6 equal to 0, so your x is negative 6. This is your lower bound, negative 6. Your upper bound is 0, so negative 6 to 0. First, you have to calculate this integral. Then you move on to the second part. Your lower bound is 0. Now you have to calculate the upper bound. To find the upper bound, you have to set x plus 6 equals to x cubed. The only value satisfies these two is x equals to 2. So lower bound is 0 and upper bound is 2. As you can see, it's pretty much complicated. Very well. Now we have to calculate the integral on the left-hand side, this integral, the integral on the right-hand side, the area on the right-hand side, and add the final answers. So on the left-hand side, you get a half x squared plus 6x. X ranges between -6 to 0 plus a half x squared plus 6x minus x to the 4th divided by 4. X ranges between 0 to 2. So if you plug in 0, it's going to be just 0. Minus a half times 36 minus 36 plus, now we plug in 2, a half 2 squared or 4 plus 12 minus 16 over 4. So this is equal to negative, so here if we just factor out 36, we get a half minus 1, negative a half, plus 2 plus 12, 14, 14 minus 4, 10. This is negative times negative, 18 plus 10 or 28. What if we use the second method that we defined here? Method 2. Taking the integral with respect to variable y. Integral of these two functions. Now you have y minus 6 and square root of y with respect to y. First of all, when you're taking the integral with respect to y, your first function is yx plus 6. Now x is y minus 6. The second function is y equals to x cubed, so x is the third root of y. First of all, you have to rewrite the functions in terms of y. And as you can see, your y ranges between 0 and 8. It makes it much more easier. So when you're taking the integral, when you're finding the area, check to see which one is easier. So by finding one integral, you can actually find the area bounded between these functions. Why is that? Because the function ranges between y minus 6 and the third root of y. You only have two functions to worry about, and your y ranges between 0 to 8. So you don't have to worry about anything. 0 to 8. And you can either use absolute value or right function minus left function. The third root of y minus y minus 6 dy. As you can see, you have y to a third, the integral of y to a third dy is equal to, so first of all, we have an exponent, 1 plus a third y2 1 plus a third, which is equal to 1 over 4 thirds, y2 4 thirds, which is equal to 3 over 4, y2 4 over 3. The integral of y2 a third is 3 over 4, y2 4 over 3. The integral of y is y squared over 2, and the integral of 6 is 6y. And my y ranges between 0 to 8. Now, I just plug in 8. I don't have to worry about 0 because all of these terms have y. The outcome is 0. So by plugging 8, I get 3 over 4. 8 raised to 4 over 3 is equal to 16 minus 32 plus 48, which is 28. So check these two methods. We used two methods. We got the exact same answer. Finding the area in between these graphs with respect to x, finding the area between these functions with respect to y. Both of them have the exact same answer, 28.